Hello everyone, welcome to this course on database versus data lake versus data warehouse versus DataMart. This course is very important because I'm discussing here what type of data storage is all about, and as a data professional we should understand which type of data storage works best in what circumstances, because each of them has their own benefits. They have their own components, their internal data structures. So it is crucial as a data professional to understand what data storage works best at what times. So I'll be discussing this in detail. So let's start. So the agenda of this course is I'll start with what is database. Then I will discuss types of databases, components of database, why is database important, what is data lake, components of data lake, why is data lake important. Then I will come to data warehouse. What is a data warehouse? What are the benefits of data warehouse? Then I will discuss how do data warehouse, database, and data lake work together within an organization. And then I will compare the differences between data warehouse versus data lake versus database. Then I will discuss data warehouse versus data lake. And finally, I will also discuss one very important type of data storage called DataMart. I will discuss what is DataMart. Then in the end, I will show the key differences among database versus data lake versus data warehouse versus DataMart. So before proceeding, in case you have not subscribed to the channel, do subscribe to watch videos like these, and I'll be making lots of uh, future videos on similar topics in data science and data engineering. So make sure you subscribe to stay tuned. All right, so what is database? A database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system, which is a software that controls the database. And together, the data and the DBMS, along with the applications that are associated with them, they are referred to as a database system, or often shortened to just database. Data within the most common types of databases in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. So similar to a pandas data frame that we use in Python, which is basically a part of rows and columns. Similarly, the database tables are just like that in rows and columns. Uh, and then that all makes the data to be accessed easily and to be managed, modified, updated, and controlled and organized. Most databases use structured query language called SQL that we use most of the time uh, for our data analysis and data science tasks to extract data from the data storage. And we use the same language for writing also to the data storage or the database, and also for querying data or to extract data from database. We use SQL. Databases are essential for storing large amounts of data in one place. With databases, organizations can quickly access, manage, modify, update, organize, and retrieve their data. So basically, a database is an essential part of data storage for any company or any organization which has data. And here you can store data by integrating data from several sources and then converting that data into a format similar to the format of your database. Because before building a database, we need to design a database schema that defines what are the tables, what are the columns and the fields, what are the uh, primary columns or the secondary columns for referential integrity constraints inside each database and inside each schema. So that is predefined, and then once that is defined, we build a database to store the data or to query the data from there. All right. So what are the types of databases? Well, they are relational databases that use a structure to identify and access data in relation to other data in the database. Relational databases are often organized into tables. Then we have object oriented databases that store data in the form of objects rather than in tables. There are no SQL databases as well. They are a broad class of database that can include document databases, key value stores, and more. No SQL databases are often used for applications that need horizontal scalability or high throughput. We also have cloud databases that can be deployed on a public or private cloud and can be any type of database. Cloud based databases are scalable solutions for growing data needs. There are hierarchical databases that use a tree like tier structure to create relationships between files. We also have centralized databases that are located, maintained, and stored in a single location, such as a mainframe computer. There are also operational databases that store detailed data needed to support business day to day operations or transactions. And finally, there are open source databases as well that are designed for public use and they are free. So anybody can contribute to that. Open source products can be modified to suit the needs of the user. So a diagram on the right side basically show how there are different types of databases, each serving basically the same purpose, storing data, but in a different format, in a different way, and having a different data structure. So it's important to understand how each of them is different when it comes to databases. So what are the components of database? Well, here are some key components. Number one is database management system, which is a software that stores, retrieves, and edits data in a database. For example, when we use softwares like MySQL or Workbench or any other software from Oracle or any other company that you use to manage, maintain, or monitor uh, your database, that's a software, that's DBMS. Then there is database system, which is a term that refers to the data, DBMS, and associated applications. The whole ecosystem is called the database system. Data modeling. So data in databases is usually modeled in tables with rows and columns to store the data and that make easier to process or to write the data or to query the data or even do another task like deleting the data or creating another tables or creating views or procedures. There are lots of things that we can do using that. And the language that we use to do all of these tasks for data modeling is called structured query language, which is SQL. And most databases use SQL to write and query data. Self-driving databases, which is a newer type of database that use machine learning now to automate data management tasks like backups, updates, and security. So that these are like predefined functions or like a lambda function that uses a machine learning model to get initiated based on some conditions. And once they're initiated, they do some tasks on your database automatically uh, using the code that you write in your machine learning model. So some examples are real life examples of databases include e-commerce platforms or social media platforms or online banking system, email services, or in fintech you have time series data, or in healthcare, so in or even supply chain. So all of that data is stored in a database. So why is database important? Because a high performing database is crucial to any organization. Databases support the internal operations of companies and store interactions with customers and suppliers. They are also used for administrative information, storing them, and for more specialized data, such as engineering or economic models. Examples include digital library systems, travel reservation systems, and inventory systems. Following are some reasons why databases are essential for every organization? Well, they provide efficient scaling, which means database applications can manage large amounts of data, scaling to millions, billions, and more in terms of number of rows or number of records. It is impossible to store this quantity of digital data without a database. It also provides data integrity, meaning databases they, they, they have built-in rules and procedures or conditions to maintain data consistency so that an outsider or people who don't have administrative rights to manage the database, they cannot make changes unless they have been given authorized access. Data security, they provide privacy and compliance requirements associated with any data. For example, to gain database access, users must log in, and that login is provided by the administrator in order to provide data security. Different users might also have different levels of access, such as read only, or some have both read and write on uh, rights. Data analytics as well you can run on the databases. So modern software systems, they use databases to analyze data. These systems can identify trends and patterns. Data analytics help an organization to make business decisions with confidence. All right, so what is a data lake? Well, a data lake is a centralized repository that stores and processes large amounts of data in its original form. Data lakes can store structured, semi-structured, or even unstructured data from any source and can process it without size limits. So the difference between data lake and database is that database always stores data in a structured way based on a schema that you define for that database table. Unlike data lake that can store data in its raw form or in its unstructured form without that is even not transformed or processed. So data just come into data lake from its source and it can be saved without making any changes in that. Data lakes are useful for a variety of purposes, including data analytics. Data lakes can be used to power big data analytics, machine learning, predictive analytics, and other forms of intelligent action. Business intelligence also provided by data lakes because they can be used to power business intelligence applications for generating insights for businesses to take important business decisions. Also, they are used for operational reporting and for business monitoring as well. So some key features of data lakes are scalability, because data lakes are easily scalable and they are often low cost. So they are not very costly to maintain or to build. They also have an open architecture, and data lakes provide core data consistency across a variety of applications. In terms of data preparation, data lakes ingest data quickly because you don't have to make data structured. So they can ingest data right away and prepare it on the fly as people access it. So diagrams on the right side show you that data lake data is coming from several different sources like cloud and IoT data movement, and then it is used from there for big data processing, for data analytics, for data reporting, and for even machine learning tasks. You can use data from data lake right away. So what are the components of data lake? Well, as organizations are building data lakes and an analytics platform, they need to consider a number of key capabilities, including data movement. Because data lakes allow you to import any amount of data that can come in real time, data is collected from multiple sources and moved into data lake in its original format. And this process allows you to scale to data of any size while saving time of defining data structures, schema, and transformations. And that's why it's not very costly to build and to maintain. Secure, uh, Securely store and catalog data. because data lakes allow you to store relational data like operational databases and data from lines of business applications and non-relational data like mobile apps, IoT devices, and social media. They also give you the ability to understand what data is in the lake through crawling, cataloging, and indexing of data. Finally, data must be secure to ensure your data assets are protected. And another capability is data analytics because data lakes allow various roles in organizations. Uh, People like data scientists, data developers, or data analysts or business analysts, they can access data from data lake with their choice of analytic tools and frameworks. This includes open source frameworks like Apache Hadoop, Presto, or Apache Spark, and commercial offerings from data warehouse and business intelligence vendors. Data lakes allow you to run analytics without the need to move your data to a separate analytics system, unlike in database where you have to do that to bring data to another system before analyzing it. While in data lake you can start analyzing the data rightly by just taking data from data lake. And finally, machine learning is another capability uh, because data lakes allow organizations to generate different types of insights, including reporting on historical data and building machine learning models, like models which are able to forecast likely outcomes or suggest a range of prescribed actions to achieve the optimal result, like forecasting methods that we used in machine learning models or predictive analytics uh, that we use. So why is data lake important? Because they power data science and machine learning, where data lakes allow you to transform raw data into structured data that is ready for SQL analytics, data science, and machine learning with low latency. Raw data can be retained indefinitely at low cost for future use in machine learning and analytics. Well, data lake also enable centralized, consolidated, and cataloged data because a centralized data lake eliminates problems with data silos like data duplication, multiple security policies, and difficulty with collaboration, basically offering downstream users a single place to look for all sources of data, whether structured or semi-structured or totally unstructured. Data lakes also enable quick and seamlessly integrated diverse data sources and formats. Any and all data types can be collected and retained indefinitely in a data lake, including batch and streaming data, video, image, binary files, and more. And since the data lake provides a landing zone for new data, it is always up to date. Well, democratize your data by offering service tools because data lakes are incredibly flexible. Uh, they allow you to use various types of tools to analyze and to process data. So data analytics tasks can be done all at once. Unlike databases, which store data in a particular format and you cannot run any analytics right away on them before taking data to an external application. Alright, so what is data warehouse? A data warehouse is a central repository of information that can be analyzed to make more informed decisions. Data flows into a data warehouse from transactional systems, relational databases, and other sources, typically on a regular cadence, at a predefined time. Business analysts, data engineers, data scientists, and decision makers access the data through business intelligence tools, SQL clients, and other analytic applications. Data and analytics have become indispensable to business to stay competitive. Businesses rely on reports, dashboards, and analytics tools to extract insights from their data, monitor business performance, and support decision making. And data warehouses power these reports, enable you to build dashboards and analytics tools by storing data efficiently to minimize the input and output of data and deliver query results quickly to hundreds and thousands of users concurrently. So a diagram on the right side shows you that scenario where data is coming from several different sources, and then you are running ETL tasks, ETL jobs, which is basically extract, transform, and load process, um, and then loading the data in your data warehouse. And from the data warehouse, you can use that data to build data visualizations for data reporting or even business intelligence. So it's just like a central repository of information that stores data by collecting data, by cleaning and transforming data from several sources, and then finally loading the data into that central repository, which is called data warehouse. Benefits of data warehouse. A data warehouse provides a foundation for the following: better data quality. A data warehouse centralizes data from a variety of data sources such as transactional systems, operational databases, and flat files. It then cleanses the operational data, eliminates duplicates, and standardizes it to create a single source of the truth. They also provide faster business insights because data from disparate sources limit the ability of decision makers to set business strategies with confidence. However, data warehouses enable data integration, allowing business users to leverage all of companies' data into their business decisions. Data warehouse can make it possible to report on themes by analyzing trends, patterns, and relationships, or by even running aggregations of the data and other relationships that it can find from that data, um, using apps like engineering lifecycle management. They also provide smarter decision making because a data warehouse supports large scale business intelligence functions like data mining, finding unseen patterns or relationships in that data, or even for artificial intelligence and machine learning models that include tools that data professionals and business leaders can use to get evidence for making smarter decisions in virtually every area of the organization, from business processes to financial management or even for inventory management. Another important benefit of data warehouse is that um, they enable gaining and growing competitive advantages because all of these uh, benefits they combine uh, to help an organization finding more opportunities, or they enable these benefits of data warehouse enable companies to uh, make their data more understandable, to make their data more usable by analyzing that data more thoroughly, to find patterns and relationships that help them to make important business decisions. And that's how they gain sustainable competitive advantages by working better than their competitors on their data. So how do data warehouses, databases, and data lakes work together? Well, the top figure it shows that data is landed into a database or a data lake. Uh, Data lake in case if you have unstructured data, and then the data is prepared from there, and from there it's selected into or loaded into a data warehouse from where we can perform reporting tasks on that data, which is in now in a data warehouse. And the figure on the bottom part, it shows once data is loaded in a data warehouse, we can analyze that data or share data with other analytics and machine learning uh, tools or models that require that data stored in a data warehouse. So this is like this showing how data warehouses, databases, and data lakes work together in coordination. All right, so what is the difference? Now we saw each of them separately. Now let's see how they are compared and contrasted together. So data warehouse versus data lake. Well, using a data pipeline, A data warehouse gathers raw data from multiple sources into a central repository, structured using predefined schemas designed for data analytics. And that is done using the ETL jobs or the extract, transform, and loading jobs that we do. Then a data lake is a data warehouse basically without the predefined schemas. So as I mentioned, data lake can store data which is raw, structured, or semi-structured. Unlike data warehouse, which always has a predefined schema or where the data is structured before being loaded into it. So data lake is just a data warehouse without the predefined schema. And as a result, it enables, or a data lake enables more types of analytics than a data warehouse. And data lakes are commonly built on big data platforms such as Apache Hadoop. Because you can use data from data lake since it's structured or semi-structured or even raw, you can use data from there to transform it into any shape. Where in a data warehouse, it's already in a certain shape. So it's more meaningful, more economical to use data from data lake uh, to transform it into any model or any type of analysis or any types of visualizations that you need to build on that data. All right, what is the difference between data warehouse versus database? Well, a database is built primarily for fast queries and transaction processing, not analytics. A database typically serves as the focus data store for a specific application, whereas a data warehouse stores data from any number or even all of the applications in your organization. A database focuses on updating real-time data, while a data warehouse has a broader scope. They capture data that's historical data that's used for predictive analytics or machine learning or any other advanced types of analysis. All right, so what is the difference between data warehouse and data lake? Well, a data warehouse, data is always structured and processed, while a data lake data is either structured, semi-structured, unstructured, or even raw. The processing of data on a data warehouse happens in a way where a schema is predefined when you are writing the data or storing the data. However, data lake uh, allows data processing where you can define your own schema when you are reading the data or you are extracting the data from data lake using some queries or SQL queries maybe. So in terms of data structure, data storage, data in a data warehouse uh, is expensive to store for large data volumes. However, data lake is designed for low cost storage. In terms of agility, data warehouse is less agile because it has a fixed configuration, which means you cannot make lots of changes once data is stored. However, data lake is quite agile and you can configure or reconfigure data as needed. It allows lots of manipulations on the data that is stored because it's highly agile, which is a big advantage. Uh, Especially when you are doing data analysis or building models. In terms of data security, data warehouse is quite mature, while data lake data security is still maturing, is still developing. The users of data warehouse are business professionals or business analysts, while users of data lake are data analysts or data scientists. So this one final type of data storage is called DataMart. So a data mart is a data storage system that contains a subset of an organization's data that is relevant to a specific business unit or department. Data marts are typically created as partition segments of a larger enterprise data warehouse. So basically, you have a data warehouse, a big data warehouse that is used by the whole organization. Now let's divide that data warehouse into small data warehouses, which are called data marts. And each department within a company has its own data warehouse called a data mart, which is used only to serve the purposes of that particular department. Well, data marts are used to analyze data more efficiently. Data marts provide summarized data that can help key stakeholders to make informed business decisions. They also enable faster data access, and they allow teams to access data and gain insights faster because they don't have to search through a more complex data warehouse. Some benefits of data marts are that they provide faster analysis because they are smaller in size, so it's faster to run queries on them. Data marts help users perform analysis faster because they are working with a smaller, more applicable data set, serving the purpose of only one particular department, like sales, finance, inventory, purchasing, or, or even data science. They are also commonly used for analytics, business intelligence, and reporting. However, data marts can also have some disadvantages, including limited scalability and integration. And data marts can be challenging to manage due to their limited scalability and integration because they are small, serving purpose of only a small group of people. So they cannot be easily integrated with your big data warehouse. They also provide reduced performance and quality if they are not designed and optimized properly. So managing them efficiently is quite important to avoid these disadvantages, which are few as compared to the advantages of data marts. All right, so finally, what are the differences among all of them? Database versus data lake versus data warehouse versus data mart. Well, a database is primarily used for storing and managing transactional data for daily operations, while a data lake stores raw, unprocessed data in its native format or raw format, while a data warehouse is a centralized repository for structured, pre-processed data for analysis, and a data mart is a smaller subset of data warehouse focused on specific business needs within a department or unit. So essentially, a database is for operational tasks. A data lake is for flexible storage of raw data. A data warehouse is for comprehensive analysis. And a data mart is for targeted analysis within a specific area of the business or a particular department within a company. So a database, it stores highly structured data, which is organized in tables with defined schema for fast access and updates. And data lake stores unstructured or semi-structured data in its raw format, and thus it allows flexible analysis without upfront schema definition, meaning you can define your schema when you are reading the data as compared to defining the schema when you are writing the data used for database or data warehouse. So a data warehouse stores structured data, which is usually pre-processed and transformed to fit a specific analytical schema. And finally, a data mart, which is a smaller data warehouse, it stores structured data, which is a subset of a data warehouse specifically focused on a particular business area. All right, so these were some of the differences that are basically important for all of us focused on data to understand and to remember so that we can use them efficiently when it comes to storing data, depending on what types of circumstances the resources available, and also most important, what are the purposes of that data storage that will be served once data is stored there. All right, hope you liked this video. Do provide your comments and do subscribe to the channel for more upcoming videos like these. Thank you and God bless you.